So 4.2, determining slope and y-intercept. Just like with our warm-up today, we took a look at 4 different graphs, and all we did was identify whether those slopes were positive, negative, 0, or undefined. Right now what we're going to do is we're going to take an equation in this form, y equals mx plus b, and we just need to remember that m is our slope and b is our y-intercept. I know we wrote something similar to this yesterday. It is that important that we got to write it twice. So, something I forgot to mention the other day when we first talked about this was how you can remember this formula. Because whenever we have a formula that's 4 variables and they're all different letters, it's going to be kind of confusing for us to remember the order that they go in and what letters we're using in general. So off to the side, I want you to write this little pneumatic, I don't know what it's called. Go ahead and write this out. It is yo mama's ex-boyfriend. All right? So, this is how we're going to remember this formula, folks. Whenever we have to deal with a linear equation, all you have to do is think about yo mama's ex-boyfriend, right? Y equals mx plus b. Y, mx, b. That's the order for this equation. All right? So if you're ever thinking about what's the linear equation, it's like a bx plus m or something like that. Just think about your mama's ex-boyfriend and you'll remember that it's y equals mx plus b. That's the order it goes in, right? Y, m, x, b. Yo mama's ex-boyfriend. All right? No, I did not make that up. I learned it when I was a student here. So I'm just passing it on. All right? So, let's talk about an example. Let's look at something familiar. Where's my blue pen? Oh. Y equals 1/2 x plus 4. So I learned about this little way to remember the formula when I was in 7th grade. So that was in 2009. That was 13 years ago. And every time I write this equation, I think about yo mama's ex-boyfriend. Okay? Even 13 years after learning it, I still think about it every time I write it. So it's proven. It sticks in your brain. All you have to do is think about yo mama's ex-boyfriend and you'll remember. All right?
I don't want to think about that.
It's okay. You don't have to think about it too hard. So, we got this equation. We're not really going to do anything with this equation except answer 2 questions. The first question is this. What is the slope? I was going to say of this line, but we'll just leave it at that. What is the slope? So what is our slope of this line? Does anyone know? I can't even see the graphed line. How are you going to find the slope, Azalea? Bingo! 1/2. Where did you find 1/2, Azalea? How did you find that? Ah, okay. So you compared this example with our linear equation, and you recognize that, hey, whatever number is stuck in front of x as the coefficient, that number is going to be our slope. So we look over here at 1/2 in front of x, and we know right away that our slope is 1/2. right? Just like the warm-up, we didn't do anything mathematical. We didn't solve anything. We identified. All right? That's the word of the day, is identify. Very different from solving, right? So we know the slope now. I'm going to ask you, what is the y-intercept? Anyone know where this graph intercepts the y-axis? Jocelyn? At 4, exactly. But where did you get 4 from?
Because an example b equals 4, or b equals the y-axis, and that's where 4 is.
Okay, so again, we're comparing this equation with our formula. Thank you, Jocelyn. And we see that, hey, this number that's being added, or we'll see subtracted in some cases, on the end of our equation, that's always going to be our y-intercept, right? So we look at this equation and see, hey, there's a plus 4 right there. So our y-intercept, b, is going to be equal to 4. Not too bad, right? Let's take a look at another example. All right, so for the second one, we got y equals negative 4x minus 6. Can anyone identify the slope of this line? Noah, what's the slope of this line? Negative 4. Thank you. So with this example, when we see the number in front of x has a negative in front of it, we know that we have a negative slope. So from left to right, if we can imagine this line in our heads, thinking about the warm-up, from left to right, is this line going to slope uphill or downhill?
Downhill.
What do you guys think? Thumbs up for uphill, thumbs down for downhill here for this line. Good. I see all thumbs down. That's exactly right. Our negative slope tells us that this line is going to slope downwards from left to right. What's our y-intercept for this line here? Anyone identify this one? Azalea, go for it. Negative 6. Thank you. So here's the next thing. Our formula is y equals mx plus b, right? Plus b. So whenever you see b being subtracted instead, that tells us right away that we have a negative value for b. So I don't want you to look at an equation like this and go, oh, it's not in the form that we need because it's supposed to be plus b, and this says minus 6. When it's being subtracted, our b value is negative. And we'll see what that looks like tomorrow. One last example for this small portion of it. Y equals 1/3 x. Y equals 1/3 x. Y equals 1/3 x. What's the slope of this line? Anyone know? Rwanda says 1/3. That's exactly right. Our slope here is 1/3. It's the number that comes right before x. That's always going to be our m, which is our slope. Now, what's our y-intercept here? Theo? 0. Thank you. How do we know it's 0, Theo?
That's a good question. I don't know.
That is a good question. Jordan, why do we know that b is 0 here? There we go. Simple as that. There's no b value there. Right? So I heard someone say that b was going to be equal to 1. That's a really good guess, okay? And I see why you would think that. But if there was a 1, or if our b value was 1, then we'd have plus 1 on the end, right? Right now we have plus nothing. So we could write in here y equals 1/3 x plus 0. If we wanted it to be in our technical form for the equation, but even without that plus 0, we still have it in linear equation form. So when you don't see something added on to the end, you know that your b value is 0. And I just thought of another good example, so let's talk about this one real quick. Fourth equation is y equals 5.
No N.
Good observation. There is no x. Just y equals a number, right?
Yeah.
So this one is a little bit different, but this is still in the linear equation form. It doesn't look like y equals mx plus b, but it is. Let's go ahead and rewrite this one. Let's rewrite this as y equals mx, where m is 0 plus 5.
So the slope is 0.
Good observation. For any value of x, what would 0 times x be equal to? 0, right? It doesn't matter what our x coordinate is. If we were to go in and plug it in like we learned how to do yesterday, we're going to get 0 right here. So whenever we have a slope of 0, we don't even need to write 0x. Okay? It doesn't give us any information we need. It just makes our lives harder. If we get rid of the 0x, look what our equation reads. Y equals 5. So when you see something like this, y equals a number, you know that your slope is what?
0.
0. That's right. Your slope is going to be 0. And what's our y-intercept going to be?
5.
Positive 5. It's right there on the end. Now, if we had x equals 5, that's a whole different story. We're not even going to talk about that right now. That's too difficult. We need a y by itself for it to be a linear equation. We need y on its own on one side of the equal sign for it to be a linear equation. And you know what? I think we are going to stop. No, we have half an hour. That's plenty of time. Oh my goodness. It's all right. Well, if we stop now, it's only one IXL.
What? What do you mean if we stop now? It's only one.
Please just stop. Mr. Church, please. Please.
So
All right. Let's go ahead and end it there. Now,
yes.
so, what day is tomorrow? Thursday?
Yes.
Okay. So here's what we're going to do. Here's the new plan. Real quick, show of thumbs. How are we feeling about this work? Identifying M, identifying B. Good. Okay.
I feel good about it.
here's what I want you guys to do right now.